So hello friends, today we'll solve the problem generate parenthesis. So given n pairs of parentheses and we have to write a function to generate all combinations of well-formed parentheses. Okay. So for example, input n is equals to 3. We have to generate all the five or all the number of well-formed parentheses with three opening brackets and three closing brackets. Okay. For example, there is a input n is equals to 1. So we have to generate all the well-formed parentheses that must have one opening bracket and one closing bracket. Okay, so we'll solve using recursion. Okay, so for example, we have n is equals to 3. Okay, we have n is equals to 3. So for n is equals to 3, we will, okay, for n is equals to 3, n is equals to 3. Okay, so for n is equals to 3, we have three opening brackets, and we have three closing brackets. Okay, and we have three closing brackets, so there are total of 6 positions, and we have to fill the proper parenthesis and generate all the well-formed parentheses. Okay, so for first position we will also be only able to we only able to put we only able to put the open parenthesis. Okay, for first position we only able to put the open parenthesis. Okay, it is not writing there. Okay, we'll write over here. Okay, so there are total 6 positions we have to fill. First position, second position, third position, fourth, fifth, and sixth position we have to fill. So for first position, there must be the opening bracket. Okay, if we fill their close bracket, so we will not able to form the well formed parenthesis in any how. Okay, so the first position must be the opening bracket. Okay, there must be not an closing bracket at the first position. Okay, so after that, there we are able to fill the opening. There are two possibilities. We will fill open as well as close bracket. Okay, after that, so okay, we will see the how we will able to so how we will solve using recursion. So the first thing is that we will maintain the two variables. First is open and second is close variable. Okay, so open variable take the have the counts of the opening bracket, and in close have the count of the closing brackets. Okay, remaining. Okay, so for initially both are 3, that is we have n is equals to 3. So we will take is that initially it is both are 3, and whenever we use the bracket, whatever the bracket, if we use opening bracket we will decrement it to the 2, if we use closing bracket we will decrement it to the 2. Okay, and we will maintain a string which contains the which contains the characters. Okay, so we'll see how to solve it using recursion. We okay, so I draw the tree, recursive tree. So we'll understand the tree how is working. So initially we have open and close, both are as we have n is equals to 3. So initially both open and close variables counts is equals to 3. Okay, so as it is first position, so we are only able to put the opening bracket. Okay, so we'll put opening bracket, and yes, its count decrements by 1, and string we will append the opening bracket to the string. Okay, now now we have the string here, we have the string like this. Okay, so this string, so we can also now we will append this also, or we will append this also to the original string. Okay, so we will, okay, so now here we will append the closing bracket. Okay, here we will append the closing bracket to the string. Okay, then the count of the close will be decrement by 1, that is it becomes 2. Okay, and we will also able to append the opening bracket. So if we append the opening bracket, the count of open will be decrement by 1. Okay, so open will become 1, and okay, so here now there is open count is 1 and close count is 3. Now the string it become like this at this position. So we now able to append this also, or we will also append this also. Okay, if you append this, there will be like this string may created. Okay, and if you append, there are three closing brackets. Okay, so there are two possibilities. Okay, so first possibility is we will append the closing bracket. Okay, append the closing bracket. So when we append closing bracket, the close count is decremented by 1 and it becomes 2. And when we append the opening bracket, so when we append the opening bracket, the sorry, there are okay, there is appended closing and there is, okay, sorry, there is a opening bracket. Okay, so when we append opening bracket, the open count becomes 0 and the closing count becomes 3. Okay, and here, now here, okay, so after that, whenever we append closing bracket, there is open count of 1 and close count of 3. Okay, so now there are possibilities like this we can append now this also, and we can append this also. Sorry, we can append this also and create thereafter like this, or create after like this. Okay, so these are the two possibilities. These are the two possibilities we can append. Okay, okay, so now whenever we append the, okay, whenever here we are able to append this also, and here we are able to append this also. So whenever we append this, the count of open becomes 0 and close becomes 2. Now we have only two options. We are able to only close the parenthesis. Okay, so there is only one option. First is close. There is no, as open is a 0, we have no opening brackets left out. Okay, so we will close this bracket and close this bracket, and yes, now the both count is decremented by, so close is becomes 1. Now one closing bracket remaining, so we will append again close. So this will our open and close are 0 0. So there is no remaining any closing brackets or opening bracket. So this is our left node. Okay, so this is our answer and we will return this answer. Okay, or push back into our vector. Okay, so this is our leaf node. Okay, this is our leaf node and this is our answer. Okay, so this is our leaf node. Okay, leaf node is when open and close becomes 0. Okay, so now similarly Similarly for here, we will appended the closing bracket. Okay, so closing bracket, so there is count of open and close both are 1. So for there is only option to append the opening bracket first. Okay, as if we append as we append this closing bracket, so this is not the well formed parenthesis. Okay, so we need to append the opening bracket only. Okay, so this is opening bracket and then open is 0, so there is only single close is left, so we will append the closing bracket and this is our leaf node. Okay, so this is our leaf node. Okay, so this is our base case actually, when open and close both becomes 0. Okay, okay, this is done. Now here, okay, here we will append it the opening bracket. So there are opening brackets, so no any opening bracket left, so there are only options, that is close bracket only. Okay, so close bracket, close to remaining, again close, then again close. So this will be the our our next our next our next leaf node. Okay, similarly for here. Okay, so whenever we appended the closing bracket, this formed like this. So there are two open brackets and two close brackets. Okay, so now we only able to append opening bracket as we appended the close bracket, so it is not the well formed parenthesis. Okay, so that's why there is only one option to append, that is the opening bracket. So whenever we append opening bracket, there are the open is 1 and the close is 2. Okay, so there is opening. Okay, so the open becomes 1 and the close becomes 2, and is as it is decremented by open is decremented by 1. Okay, now there is the we will append this. So there are two options, we can append. We can append this also, and we can append this also. Okay, if you append this, there is later on this will be create well formed parenthesis, and this will also created well formed parenthesis. So there are two options. Okay, we also append the opening bracket and we also append the closing bracket. Okay, so first if you append if we append the okay if we append the closing bracket and if you append the opening bracket, if we append the opening bracket, then the open becomes 0 and close becomes 2. So we have only two options to close the, so there is only closing bracket and there is also closing bracket. So this is our leaf node. Okay, this is our leaf node. Okay, second, if we okay now we appended the closing bracket, so we have open one and close one. So at the time append we only able to append the opening bracket. As we if we append okay sorry if we append here the closing bracket, so this is not the well formed parenthesis. Okay, it will create like this. So this there is only option to append the opening bracket. Okay, so we will append the opening bracket here. Then there will be now there is only single closing bracket left, so we need to append the closing bracket. Okay, this is our fifth leaf node. Okay, so we formed all of the five parentheses using recursive tree. Okay, so this is our recursive tree. There are fifth, six position, and we understood how to append and when to append. Okay, so first thing we carefully observe that whenever the open and okay first thing is base case. Okay, so we will write over here. Okay, we'll write over here. First thing we observe is that whenever open and close both becomes 0, we simply need to return. This is our leaf node and this is our answer. Okay, so this is our base case. Okay, so whenever if close close is equals to 0 and open is equals to 0, we simply need to store somewhere where that is we if we using vector, so we will simply push back our answer. Okay, push back our answer into the and simply need to return. Okay, the second is that whenever our open whenever our open see whenever open and close are same, at that time we only need to okay so we'll see okay the second observation is that whenever open is greater than close, see whenever open where is open okay sorry open is less than close. Okay, whenever open is less than close, we only able to append the the closing okay closing bracket. See, there is open is less than 7, so we only able to push the closing bracket. Okay, here see here we also able to see whenever there is open is less than close, we only able to okay, so we first observe that whenever our open is less than close, that is close have the greater value, we always able to append the closing bracket. Okay, that is C. Here also there is whenever the close is greater than, we are able to append the closing bracket. Okay, we are able to append the closing bracket whenever close is greater, we are able to append the closing bracket. Okay, see there is also okay whenever the close is greater, then only we are able to append the closing bracket. See, we both are same, we are not able to append the closing bracket. Only when we are able to append the closing bracket when the open is less than close. Okay, then only that time. Okay, so whenever if open is less than close, if open is less than close, then only append only append the closing bracket. Okay, and the one we saw is that whenever we have the value of open, whenever we have the value of open as not equals to 0, at that time we able to append the opening bracket. Okay, see, there is open have some value, so we are able to append the opening bracket. There is open have value, we are able to append the opening bracket. There is also open, okay, there is also open have value, we are able to append the opening bracket. When there is open value, we are able to append the opening bracket. Whenever the open is not equals to 0, whenever, okay, if it is equals to 0, then we have only option to append the closing bracket. Okay, so whenever the open have some value, we are able to append the opening bracket. Okay, whenever. Okay, so the second is if, first thing is, okay, open if open, this is actually first because it is starting from open have some value. Okay, so thereafter it will be open value is deducted. Okay, so if open is not equals to 0, is open is not equals to 0, then append the opening bracket. Okay, as it is starting point, so we need to write this condition before this. Okay, okay, so we will write the code for the same. So hope you understood the recursive tree. So now we'll write the code for the same. Okay, so okay, so okay, so first thing is generate parenthesis. Okay, so what we will do, we have the if n. Okay, n is the number of open brackets and close brackets allowed. Okay, so int open is equals to n, and int close, which is also equals to n. Okay, thereafter we will maintain a vector where we will store all the well formed parentheses answer. Okay, and we will call some recursive function. Okay, in that first one is int open brackets, then int close brackets, and then the string, which is our answer, then the next is will pass the answer. Okay, and then we'll return only the, okay, we'll see, first we'll see the recursive code. Okay, the first thing is that we doesn't write anything, doesn't return anything, void solve. First is int open, second is int close, then third is a string, that is our answer, string answer. Then next is vector, always pass it by reference, string. Okay, and this ampersand, our answer. Okay, so in that what we will do, first, base case, our base case is what, our base case is what, our base case, our base case is what, whenever whenever our whenever our open and close becomes 0, this is our base case. Okay, and we simply return at that time. Okay, so if, okay, so if our open is equals to 0, percent, and close is equals to 0, at that time we'll only store the answer, that is answer dot push back our string. Okay, that is the answer string, and simply return. Okay, then the next is that if our open is not equals to 0, open is not equals to 0, at that time what we will do, recursively call the function open is deducted by 1 and close becomes as it is, and the answer plus we need to append the opening string, okay, and the answer as it is, okay. And the second case is when if our open is less than close, this case, if our open is less than close, at that time only we are able to append the closing bracket. See, in all the conditions we are able to append the closing bracket only when the open is less than the close, okay. So if open is less than close, at that time we will recursively call the same function with open as it is, close minus 1, and append the answer of answer closing, okay, and comma, it's not an answer, okay, it's okay, it's same, so we'll write it as with tr and yes, yeah, it's a vtr, okay, okay, vtr, okay. And at the last, so we will call the same function, and at the last what we will do, we will return our answer, return answer, okay. Oh sorry, there is not an if I need again, there is an answer. So it's not actually answer, it is just a empty string we need to pass initially, okay. And this is the vector, so we'll return answer at last. So now we try to run it. Okay, both test cases are passed, so now we try to submit it. Yes, it's working well. So thank you for watching the video. Like my video and subscribe my channel. Thank you so much.